Example number 4. Example number 4. Which one did it match with?
B. Yeah.
We'll talk about why in just a second. Example number, let's see, example number 6.
C.
We'll talk about why in just a second. Example number 5.
D.
And example number 7.
A.
Now, I'm going to talk about a couple of these. This is how I always do these. I pick an order pair. Any order pair, it's your choice. Pick an order pair, and I plug it in. Okay? That's how I'm going to do this. That's personally how I did it. So I started with, I actually looked at these and I was like, well, let's see. I chose 0, 1 because 0, 1 has a lot of different, there's a lot of different, like 3 out of the 4 have different types of slopes than 0, 1. If you stick in 0, 1 into number 4, what kind of slope do you get out? You stick the order pair into here, what do you get out? 1. If you stick 0, 1 into here, what do you get out? -1. If you stick 0, 1 into here, what do you get out?
1.
And if you stick 0, 1 into here, what do you get out?
0.
Wait, that's kind of smart.
So, at 0, 1, my slope is 0 on that point. So I'm good with that one. This one has a slope of -1, so I need to figure out which one had a slope of -1 at 0, 1. Well, that would be this one. This is the only one that has a slope of -1.
Yeah.
So now it's between these two. So now I pick a different point. Maybe 0, -1, because I look at these two, or even 0, 0, because these two have a different slope of 0, 0. So if I plug in, I'll do it black. If I plug in 0, 0, and I only care about, we've already done A and C. This one, I get out 1, but this one, I get out 0. There's my B, and there's my 0.
Is this ever going to be on the AP?
Yep.
It was. It's in the
Yep.
workbook.
Yep.
In the workbook. It's like
So,
not
a couple things. I want you now to decide which of these can you find me the original functions. Can you find me the original functions for all of these?
No.
5 and 7.
5 and 7. I agree. Can you find me the, why can't you find me 4?
Because they're +1. Because of the +1.
I can't, okay, so let's talk about 4.
You want -1? You can divide that. No, you can't.
No, you can't.
Not.
dy dx equals 1/2 x plus 1. So you all said I can't integrate that. I can't!
Oh, you can integrate it.
How?
dy equals 1/2 x plus 1 all times dx.
So you split it up.
Well, you always remember if I am integrating, am I separating and integrating?
Normal.
So you get your y's on one side, get your x's on the other. I did.
So it's just normal integration.
You said it too.
I know, but then I
Hey, I can integrate this.
H for
Y equals
that.
1/4 x squared.
It's plus C.
I have a question. Please, if I tell you the initial value, or sketch, I don't care which initial value you choose. Choose the initial value 0, 1, because that's what we used in here. For B, plug the initial value of 0, 1 in there and draw me a sketch. Plot the initial value of 0, 1 on B and draw me a sketch.
Wait, Michelle.
Yeah?
0, 1.
Plot me the initial value of 0, 1
Wait, so it'd be 1
on B.
Can you scroll down for me real quick? Sorry.
And draw me a sketch.
Okay, thank you.
It's like
Yeah.
ladies and gentlemen, shouldn't it be a parabola?
Yeah.
Shouldn't it be a relatively wide parabola?
Because it's 1/4
Because
x
it's 1/4 x squared. Hey, do you notice that these are all shifted to the left too? All those have horizontal asymptotes right there. That's your vertex. All right. See, I agree with number 6 that you cannot separate or integrate that. I would like for you, let's do number 5, example 5, dy dx equals y. Please find me the original function.
Wait, 4, 5, and 7 all can be integrated.
4, 5, and 7 all can be integrated. Not 6. 4, 5, and 7 can all be integrated, not 6. I want you to integrate 5 for me. Just the other way.
I did everything.
Y, negative y, negative 1 over y squared, x plus c. 1 over y squared plus minus 4 over y
Wait,
squared.
where does the plus c go?
I know I'm done. Yes? I have a question. I would like you to plot the point 0, 1 on D and draw me the sketch. Plot the point 0, 1 on D and draw me the sketch.
Doesn't it go this way?
Isn't that an exponential function?
Yeah.
I would like you to plot the point 0, negative 2 on the same graph. Plot the initial point 0, negative 2 on the same graph and draw the sketch. Hey, if C is if 0, negative 2 is my original point, doesn't that mean this graph is flipped over the x-axis? Here, C is going to be negative. Look at that. 2 different graphs depending on which way C is. So initial values are key. All right, and now I want you to do 7.
Yeah.
I want you to solve for y squared. Actually, I don't want you to solve for a y. I want you to solve for y squared. You should have gotten y squared equals negative x squared over 2, negative x squared plus c.
Yeah.
Because you multiply by 2 and c times 2 is still c. I'm going to move the x squared to the other side.
Isn't that a circle?
I have a question. What's x squared plus y squared equals c?
A circle.
Hey, I have a question for you. If you look at A, what does it make?
A circle.
It's amazing. My slope fields match my equation. Slope fields do not have to give you out functions. Oh, look at that. It's amazing how that works. All right, so. So, here we go. I actually want to come back to this. I'll look back to the beginning. And I want you to highlight, put a box around, do something with this. Euler's method. This is called Euler's method. And Euler's method says, Euler, yep.
Wait, where now?
At very front. Euler's method. Euler's method says the new y equals the old y plus step times y prime. I'm going to explain it in just a second. I just need you to write this down. Yep. New y equals old y plus step times y prime. Let me explain. What Euler's method does, it allows you to figure out what an approximation of a y value, really close to it, the actual y value, without having the original equation. Just using the derivative you're going to find out what the y value is without having the original equation. Now, here's what I need you to have. I need you to have your calculators out because Euler's method will be done with a calculator. Okay? I need you to have that out, yes.
Can this replace the
Nope.
method where it's defined?
Linear approximation?
Yeah.
Nope.
Like the closest point to the curve or something like that?
No. Yes. No. That's optimization. No. No. It will say use Euler's method to prove.
And it's
Yeah.
always calculator.
Yeah. 90% of the time because it's so much easier with a calculator. Alright, so here's what I need you to do. You ready? Okay. We're going to do a chart. Okay. Here's the first thing you have to recognize. Well, my derivative is y prime equals x plus y. Everyone got that? So dy dx equals x plus y. They tell me that. You have to know what your step size is. I'm going to tell you that. Right? Or I'm going to tell you how many kids going to say 3 equal steps or something like that. You have to know what your step size is. Figure out either I tell you or you can figure it out. You have to know what your step size is. And you have to know what the initial value is. So step size is kind of like delta x. Step size is kind of like delta x. Okay? So my delta x is 0.1. That's my step size. And I have step size. And I have the initial value of 0, 1. And I'm looking for y of 0.5. So this is all of this information that I have on the right hand side. It's all the stuff that we already know. I'm just writing it down so I know exactly where it is. Everyone okay so far?
Yes.
Okay. I'm going to make a chart over here. Oh, what did I do? Okay. Here's how I do it. I do a 4-column one. There are people that do different ones. This is how I'm going to show you. It's just for my brain, this works better. So whatever works for your brain, I don't really care how you do it. This is how I'm going to set it up. I'm going to have an x column. I'm going to have a y column. I'm going to have a dy dx column, and I'm going to have a new y column. The y column and the y column are going to kind of match. Makes sense. I'm going to fill in what I know first. The first thing that I know is I know I'm starting at 0, 1. Because they gave that to me as my order pair. I know the step size is 0.5. Which means, or 0.1, sorry, 0.1, which means my next x value is 0.1. And my next x value after that. And then, and then, and last, because that's what I'm looking for. So when I find this y right here, I'm done. Because that's what I'm looking for. I'm looking for this one right here. I'm going to highlight it, actually, just to remind myself. When I fill this spot out right here, I'm done. Because that's what I'm looking for. Right? That's what I'm looking for. So when I fill that out, I'm going to be done. All right. So let's go back. If I plug in my order pair, 0, 1, into dy dx, what do I get out? 1. My new y. Remember, my new y, I said, is the old y plus my step times y prime. So, my old y plus my step times y prime. 1 plus 0.1 times 1.
1.1.
That's my new y. So that goes right here. I need to do the work here. It's just easier for me to, you technically don't have to have this third column, or fourth column. I think it's easier to do the work and then shift it over there. My personal brain works that way. If I plug in 0.1 and 1.1 into dy dx, because that's my x and y now. What do I get out? 1.2. So my new y, I get it by going my old y, which is 1.1, plus my step, which is 0.1, times my new y. Or times my dy dx, sorry, times my dy dx. My calculators are helpful. What is it? 1.22? Just straight 0.22?
Is this always going to be on calculator?
Yes, unless they're nice numbers. They can put it, if they put it on non-calculator, it means
Like
that when you
step
do this,
size.
it's, yeah, step size was 1, step size was 3. I could put it on non-calculator. Everyone okay with how I got 1.22? Alright, now my new dy dx. 1.42. So my new y is going to be my old y, 1.22, plus delta x times new step times dy dx. Somebody tell me what it is, because I don't have it written down. 504? Do not round these, ladies and gentlemen. You did not get that?
I got 1.36.
That's what I got.
1.362?
Yeah.
Okay. 1.362. Alright. Alright. So then my dy dx is going to become 1.762. How about 662? 1.662, right? Yeah? Yes, no? So now this becomes 1.362 plus 0.1 times 1.662. 1.5282. Somebody check Amber's math.
Yeah.
Fabulous. So my dy dx, 1.9282. 1.9.
Boy just sat here.
Yeah, oil over here. Just chilling, doing his garbage.
0.1 times,
Man,
1.9.
what'd you get?
what'd you get?
1.7210.
That's what I got.
1 what?
That's it, we stop now.
Yeah, stop.
Isn't it nice when you highlight so you're like, oh, I'm done?
Yeah.
Which means, ladies and gentlemen, y of 0.5 is 1.72102, or approximately 1.721.
That's just an approximation. Is that the
Yeah, it's approximation. It's really close to it, but it's an approximation. We okay so far?
So far. Is that not the end of the problem?
That's the end of this problem, yes. That is the end of this problem. So I have found estimated y of 0.5, not knowing the initial problem at all. And I couldn't find the initial problem either. Notice that, right? I couldn't separate and integrate. I couldn't find the initial problem. I have no clue what the initial problem is. I could not separate and integrate, but I get what y of 0.5 is, knowing this piece. All right.
This is all gonna be under recording.
Oh, yeah.
Wait, it's on.
Uh-huh, because I'll